So next question, if A is an orthogonal matrix, then which of the following is true? First option, determinant of A is equals to 0. Second option, determinant of A is equals to plus or minus 1. Third option, determinant of A is equals to plus or minus 2. Fourth option, none of this. So this question was asked in PGCET 2020 for 1 mark. So let us see the solution. Before solving this problem, we should know some of the properties of determinant to solve this problem. So first property is, for any square matrix A, determinant of A is same as determinant of A transpose. If you consider any square matrix A, determinant of that matrix is same as determinant of its transpose. For example, suppose if you consider A as any square matrix, I will consider a square matrix of order 2. Let the elements be 1, 2, minus 1, 4. Now determinant of A becomes this into this. 1 into 4 becomes 4 minus 2 into minus 1. 2 into minus 1 becomes minus 2. 4 plus 2. 4 plus 2 becomes 6. So determinant of A is 6. If you consider A transpose of a matrix means you have to interchange rows and columns. So I will write first row as first column, second row as second column, minus 1, 4. Now determinant of A transpose is again 1 into 4, that is 4, minus 1 into 2, that is minus 2. Again 4 plus 2 becomes 6. Clearly we can conclude that for any square matrix, determinant of A is same as determinant of A transpose. Second property, for any two square matrices A and B of the same order, determinant of A into B is equals to determinant of A into determinant of B. So again I will give one example. Suppose A is equals to, consider the matrix 1, 2, minus 1, 6. B is equals to matrix 2, 1, 2, minus 4. Now determinant of A becomes 1 into 6, that is 6, minus 2 into minus 1, minus 2. So 6 plus 2 becomes 8. So determinant of B becomes 2 into minus 4. So that is minus 8. 1 into 2, minus 2. So minus 10. Now find the value of AB. Matrix AB is equals to, so first row into first column, that is 1 into 2, that is 2, plus 2 into 2 becomes 4. Again first row, second column, 1 into 1, 1, 2 into minus 4, minus 8. Second row, first column, that is minus 2, plus 12. Second row, second column, minus 1, minus 24. So that is equals to 2 plus 4, 6, 1 minus 8 becomes minus 7. Here minus 2 plus 12 becomes 10. Minus 1 minus 24, that is minus 25. Now determinant of AB. Determinant of AB becomes 6 into minus 25, that is 6 into minus 25 becomes minus 150 minus 7 into 10, that is minus 70. So minus 150 plus 70 becomes minus 80. So we can see here, so determinant of AB is minus 80. So determinant of A into determinant of B. So determinant of A is 8. Determinant of B is minus 10. So again 8 into minus 10 becomes minus 80. So this is the second property we have to remember. Determinant of AB can be written as determinant of A into determinant of B. Third property. So determinant of identity matrix is 1. So if I is the identity matrix of any order, so its determinant is 1. Suppose if you consider identity matrix of order 2, it is of the form 1 0 0 1. So if you find the determinant of this one, what we will get? 1 into 1 minus 0, that is 1. So if you consider I as the identity matrix of any order, so its determinant is 1. So now we will use these properties to solve this problem. So they have given A as an orthogonal matrix. Orthogonal matrix means any matrix A is said to be orthogonal if A into A transpose is equals to identity matrix. If A into A transpose is identity matrix, then we are going to call A as the orthogonal matrix. So we have to check the determinant, whether determinant of the matrix A is 0 or plus or minus 1, plus or minus 2, none of this. So I will take determinant on both sides. So taking determinant of both sides, I can write it as determinant of A into A transpose is equals to determinant of identity matrix. So as we have seen second property, so that is determinant of product of two matrices. What we can write? Determinant of A into determinant of B. So by using this property, I can write determinant of A into A transpose can be written as determinant of A into determinant of A transpose, that is equals to determinant of identity matrix. We have seen determinant of identity matrix is always 1. So again that is equals to determinant of A from the first property. What we have seen, first property, determinant of A is same as determinant of its transpose, that is determinant of A transpose. So in case of determinant of A transpose, I can write determinant of A, so that is equals to 1, or determinant of A into determinant of A becomes determinant of A whole square is equals to 1. So taking root on both sides, determinant of A becomes plus or minus 1. So the correct option is option B, that is determinant of A is plus or minus 1. So if A is an orthogonal matrix, then determinant of A is plus or minus 1. Next question, the value of the determinant is, so they have given determinant of 11, 12, 13, 12, 13, 14, 13, 14, 15. So 4 options are given, 0, 1, minus 1, 2. So this question was asked in PGCET 2020 for 1 mark. So let us find the solution. So these type of determinants, if you see the determinant here, so numbers are consecutive numbers, 11, next number is 12, 13, here 11, 12, 13, 12, 13, 14, 13, 14, 15. So determinant of consecutive numbers is always 0. Suppose any determinant of this form, n plus 1, n plus 2, n plus 1, n plus 2, n plus 2, n plus 3, n plus 3, n plus 4 is always 0. If you consider any determinant of this standard form, its value is always 0. So no need to expand this determinant. So directly we can take the value as 0. Suppose consider the determinant of 100, 101, 102, 101, 102, 102, 103, 103, 104. So I can write the value of this determinant as directly 0. Okay. So remember this one. If the given determinant is of this standard form, we can write its value as 0. Find all t such that determinant of t minus 4, 3, 2, t minus 9 is equals to 0. We have to find the values of t such that determinant will be 0. So this question was asked in PGCET 2020 for 1 mark. So very simple problem. Solution. So they have given determinant of t minus 4, 3, 2, t minus 9 is equals to 0. Expanding the determinant. If you expand the determinant, so this into this, that is t minus 4 into t minus 9 minus 3 into 2, that is 6 is equals to 0. So expand. So t square minus 9t minus 4t, that is minus 13t minus 4 into minus 9 plus 36 minus 6 is equals to 0, or t square minus 13t, 36 minus 6 becomes 30 is equals to 0. So this is the quadratic equation in terms of t. So if you solve this equation, we will get the value of t. So here product should be 30 and sum should be minus 13. So we have to choose numbers whose product is 30 as well as sum as minus 13. So we can take minus 10 and minus 3. So t square minus 10t minus 3t plus 30 is equals to 0. Or from these two we can take t as common, t into t minus 10. From these two we can take minus 3 as common. So minus 3 into t minus 10 is equals to 0. So that is t minus 3 into t minus 10 is equals to 0. For the value of t becomes 3 and 10. So the correct option is option A, 3 and 10. Otherwise, so in this equation here or in this quadratic equation, you have to substitute different values and you have to check whether the value you are getting 0. So like this also we can solve. If it is not getting 0 means we can eliminate that option. Next question. The system of equations kx plus y plus z is equals to 1, x plus ky plus z is equals to k, x plus y plus kz is equals to k square have no solution if k equals to 1, 0, minus 2, minus 1. So this is 1 mark question asked in PGCET 2020. So solution. So any system of equations we can write it in the form of Ax is equals to b, where A is the coefficient matrix, x is the column matrix containing variables, b is equals to the constants containing RHS of the equation. So if you consider the coefficient matrix A, if the determinant of A is not equals to 0, then the system of equation have unique solution. So again, if determinant of A is equals to 0, then the system may have either no solution or infinitely many solutions. So they have asked have no solution if k equals to. So what we have to consider, since no solution means determinant of A should be 0. So if you consider determinant of coefficient matrix, so we have to consider the coefficients of the variables x, y and z. In the first equation, coefficient of x is k, y is 1, z is 1. Second equation, coefficient of x is 1, y is k, z is 1. Third equation, 1, 1, k. Since we have no solution, so what we are taking, determinant is equals to 0. Now if you expand this determinant, so that is k into this into this, that is k square minus 1 minus 1 into k minus 1 plus 1 into 1 minus 1 into k, that is equals to 0. So implies k into k square becomes k cube minus k, here minus k plus 1 minus k is equals to 0. So implies k cube minus k minus k minus k, that is minus 3k plus 2 is equals to 0. So if you solve this equation, so you will get the value of k as 1, 1, minus 2. So whenever k is equals to 1 or minus 2, it may have no solution or infinitely many solutions. But if you take k is equals to 1, so if you take k is equals to 1, what happens? First equation is x plus y plus z is equals to 1. Second equation again, if k is 1 means x plus y plus z is equals to 1. So third equation also becomes x plus y plus z is equals to 1. So all equations are same. So all equations are same means so x, y and z have infinitely many values we can take. So x is equals to 1 is not possible. So the possible is when when k is equals to 1, what happens? The system of equation have infinitely many solutions because all equations are same. So the required answer is k is equals to minus 2. When k is equals to minus 2, the system of equations have no solution. Next question. Let A is equals to matrix 1, 2, minus 5, 1 and A inverse is equals to x into A plus y into I. Then the value of x and y are, so options are given. So this question was asked for 2 marks in PGCET 2020. Solution. So one method is you have to find the value of A inverse. So A inverse means 1 by determinant of A into adjoint of A. Then you have to substitute and you have to solve this equation. So that is lengthy process. Otherwise, so for the given equation, they have given A inverse is equals to x into A plus y into I. So if I multiply throughout the equation by A, so A into A inverse is equals to x into A plus y into A into I. So A into A inverse becomes identity matrix is equals to x into A, that is A square plus y into A into identity matrix becomes A. So instead of solving this equation, we can consider its equivalent equation, that is I is equals to x into A square plus y into A. So let us substitute the values. A square means, so that is A into A, given matrix is 1, 2, minus 5, 1. Again if you multiply with 1, 2, minus 5, 1. So you will get first row, first column, that is 1, 2 into minus 5, that is minus 10. First row, second column, 1 into 2 plus 2 into 1, that is 2. Second row, first column, that is minus 5 into 1 plus 1 into minus 5. Second row, second column, minus 5 into 2 minus 10 plus 1 into 1. So the value of A square becomes minus 9, 4, minus 10, minus 9. So now substitute the values. So here I means the identity matrix. So given matrix is of the order 2. So we have to consider again identity matrix of same order, that is 1, 0, 0, 1 is equals to x into A square. The value of A square is minus 9, 4, minus 10, minus 9 plus y into A. A means 1, 2, minus 5, 1. So equating the elements, corresponding elements, what we can write, 1 is equals to, here first element, 1 is equals to here minus 9x plus y. Again second element 0 is equals to 4x plus 2y. So to find the values of x and y, we need only two equations. It is enough. So what we can write? So solve these two equations. So first equation is minus 9x plus y is equals to 1. Second equation. So second equation I will write as 2x plus y is equals to 0. So I am dividing throughout this equation by 2 because in the previous equation coefficient of y is 1. So to make coefficient of y as 1, I am dividing throughout by 2. Now if you solve these two equations, so this minus this gives minus 11x, y will get cancelled, is equals to 1. Our x value becomes minus 1 by 11. So substitute the value of x in any one of the equation. Suppose if I substitute in second equation, that is 2 into x means minus 1 by 11 plus y is equals to 0. Our y value becomes how much? Minus will become less, that is 2 by 11. So the required answer is x is equals to minus 1 by 11 and y is equals to 2 by 11. So that is x is minus 1 by 11, y is 2 by 11. So correct option is option A.